Hey, well, thanks for the opportunity to get in front of everybody again. Always a pleasure. For those of you watching this who might not know who I am, I'm the VP of Sierra Dental Tool. I have a really in-depth lab background. I ran a milling center for 10 years. And my elevator pitch on that is that I've literally broken and fixed everything in the digital process. So we're pretty good at figuring out ways to help labs work more efficiently. And then on top of that, I'm in this new, in the last 3 years, I've been in this position with Sierra that's highly unique because I've got exposure to so many different labs and situations through our partnership with Zahn. So with that, I've got a couple of slides that we'll run through here, and I'll try to keep it in the quick bite time scale, and we'll jump through it here. So I don't think that anyone disagrees that digital is here to stay in our industry, and for most labs, it's really changed the game. But when you look around, and the observant among us will realize that the digital is pretty much saturated the market. It's hard to walk into a dental lab nowadays that doesn't have at least some digital process in their lab, and that could be as low, as simple as just having a scanner to, having 20 milling machines in a room full of 3D printers. So it really doesn't matter if you have digital now. It's kind of a requirement if you're going to be relevant as a dental lab. What matters is how you use it and how it's implemented in your business. And so that's basically what I want to go over here. And you'll find that my presentation style, I'm not really reading slides or doing anything. I'm just running through it and using the slide as an anchor point for my talking freely. So what I'm going to go over real quick is some ideas on digital process in the lab, some top tips, and maybe some ways to manage your consumable spend a little bit more efficiently. As you guys may know, Sierra Dental Tool, we manufacture the tools for mills, but that's indirectly related to all the different mill processes because they all feed into that tool. So I've started broadening my presentations, from, hey, here's a tool, here's why it's awesome, here's how it's going to save you money, to, let's look at the entire process and show how a good tool fits in that process. So the majority of this is all on process. The first thing that I tell labs that I'm talking to is think about your mindset. The problem is that there's not one good answer for every lab. There's not like a one size fits all thing. But the largest common denominator among all labs is the mindset and how they look at their production process. And if you look at how you're doing your production in a pragmatic and analytical way, and when you make changes, you control variables. Think about the scientific process. Don't change 7 things at once because you won't know what the effect of that change was in your process. If you take anything away from this, that's the biggest thing, is when you're looking at your process and trying to find efficiency, be in the mindset of analytical and variable control. So what is a good process? What do you need to get a good process other than a mindset? You need good inputs. There's an old kind of saying that I'm sure everybody knows: if you put crap in, you get crap out. So you got to have good materials. You have to have good machines. You have to have good people. All the inputs into your process make the process. And then another addition to that is the mindset thing. Is you always want to have mindset of constant improvement. Look around in your lab and, hey, there's dust piling up in that corner. Why? Is there a door that's leaky, or you have a draft? Like fix the root cause of even the smallest problems, and they'll go away. And the whole entire hair on fire situation will be reduced a lot if you're constantly trying to improve. Never stop improving. So I've got a couple of thoughts on inputs. When we're talking about what's going into your process, you can divide that up into some pretty big categories. Like the top four essentially in a digital machining process are your machines, obviously, your software, which is both the CAD side and the CAM side, highly important. What materials you're using, and then what tool have you employed in the process. And if you make decisions around each one of those points in the right way, not only can you be successful with digital, you can also be extremely profitable and sustainable, and it can be really good for your lab business. So with that, a little detail on each one of those points. Okay, I get asked this a lot. What machine should I buy? And I'm basically, I'm impartial. We make tools for all the machines. So it doesn't really matter to me wearing the Sierra hat what machine a lab buys, because we know we can deliver regardless of what they choose. And so the way that I answer that question is the hardware good? Yes, all the hardware is good. It's all about the relationship with your vendor on the machine. How well supported is it? Can you get parts when it breaks? Because it will break. All machines break. And just consider the relational aspect when you're making an investment like that. And on a daily basis, guys, I deal with the Zahn team. World class. Like you can't do better. So obviously I'm going to point a little bias on that. Then when you're looking at how difficult is it to maintenance, how difficult is it to keep it up and keep it reliable? I'll tell people to download the user manual for the machine you're considering to buy and read it and get an idea of what is it going to take on a daily basis to keep this thing running. There's pretty drastic variance depending on what you decide to use, and then also look at what do parts cost? What does it cost to have a service tech out? All of these things come into play, and you should calculate that in your ROI. It's not just cost of machine; it's cost of machine and operating and maintaining the machine. All right, moving on here. A little bit of fun on software. So you have two major points on software when we're machining dental prosthesis. I just call them parts. It's the design, which is obviously more on the input side of the process. And that's very important. You can choose a closed system or an open system. There are benefits and drawbacks to those. Generally, I think the feel is to go open nowadays because of the flexibility that it gives you from a business standpoint. But then also on the other side, closed, you have generally easier implementation for closed. And then on the CAM side, you also have a similar choice to make. Some of the machines out there come with a closed CAM. Those usually work well turnkey, and you can make crowns and kind of forget about it. But the problem is when you want to add something new, or you want to do something flexible, or something maybe off label, which is really common. Us labs like to innovate and do things differently. That's when an open cam really shines. For instance, Zahn has partnered with Sin Systems for the Millbox product. That is an open cam. It's it's way more customizable than really anybody even realizes. And then there's a couple of other competitors out there in the field too. But to sum that up, when you're looking at software, again, you got to answer the open or close question. That's probably the biggest one. And then second is, are you dealing with a dealer that has a couple of thousand installs out there? Can they support you? Can they help you do what you need for your business case? All that's really important. A little bit more detail on design. It's very uncommon it's uncommon to walk into a lab and see that they've actually tweaked their design side to a point where it's really good. Usually you're taking it out of the box, using a default configuration, and those work well. But the design settings ideally are tuned for the production process. So for instance, if you design a crown for 3D printing and you design a crown for milling, those are going to be completely different crowns because the process is different. But on a more micro scale, if you design a crown for one machine and one tool set and one CAM software, that combination, it's going to be different from a different machine or a different CAM software. And so really the default configs that are like implemented out there are generally, I like to call them like the minivan of configuration. It's like, how do we hit all these boxes and make something that works? I think the point that I'm trying to make with this slide is that if you analyze your settings and maybe work with your dealer on getting those perfected for your process, you can pick up a lot of efficiency off the default shipped setup. Cool. So I am going to run through these pretty quick because I've still got 87 slides left in 10 minutes. Okay. So now let's talk about what we're doing on the consumable side. So we've checked the box of machine, software, all that's dialed and perfect. The biggest, when you look at all this from a business case scenario perspective, where the biggest dollar savings or dollar efficiencies are for digital production is in the consumables. And so you really want to make sure that one, you're using a good consumable, and two, you're using that consumable to its highest potential. And so I'll dial in on materials and tooling. A lot of this crosses over to 3D printing too. In case you're looking at that, but we happen to be a tooling company, so I'm kind of biased towards subtractive manufacturing. Okay, so on materials, quality, guys, like the Zirconia is crazy. There are so many variations of Zirconia out there now. Back 10 years ago, there was only a handful, but as markets grow, more people come in, and I would say half the Zirconia out there, well, I'm not going to go that high, but a good chunk of the Zirconia out there is questionable as far as where it comes from. And, is it really FDA cleared? Like, have you done your homework to make sure that it is? There's even been some articles around some of the powders being radioactive. Like, there's some scary stuff out there, and you really need to know about the quality of your material. And work with a reputable supplier for that. Getting material from a guy who's bought a pallet of it from China and he's selling out of his garage, yeah, you're going to save a couple bucks. But what happens when your remake level spikes 3 years from now because you put out 500 crowns or 1,000 crowns in this crappy material? Definitely consider the risks when it comes to material, and really, it's better to spend a little bit more and make sure it's reliable. So that said, you're just going to reduce, your overall frustration level. I know I've worked in labs. I know how it is, and you know, most labs that I've even, you know, walked into or talked to, there's always a good degree of like that hair on fire factor. Like, oh crap, we got a breakage. Oh crap, we got a rush case. Oh crap, you know, there's a lot of that going on. And so if you cover the basis of good materials and good inputs, machines, software, tools, everything, you don't have to worry about that. You can deal with your clients and focus on doing better with your business. Okay, so one other thing on materials, I've got a couple of quick tips that'll make a difference to your bottom line no matter what. You should always be getting at least 18 units in a standard 98 millimeter disc. And if you don't know how many units you're getting, track it. It's easy to write it down, like yellow pad. Write it down, hash marks, track it. If you're not getting 18, you're not making good use of the material. And how do you get 18? These 3 points here. When you're nesting, do not create islands. Don't create little areas of material that you can't use. Also, do not create peninsulas. Like, think about the state of Florida. If you have the state of Florida in your puck, you can't put a unit in the end of that peninsula because there's nothing to attach it to. And then thirdly is, no matter what CAM system you're working with, the majority, I would say all of them, have the option to overlap the space around the unit. So you can either set a unit, you know, down in its own little pocket, and then the next one next to it, and keep walls in between all of them, or you can bring them all together and overlap that. The difference in your material yield is like 15 or 20% if you overlap the offsets. It's massive. And that scaled across thousands of units in a year is way bigger, you know, when you look at it from a dollar point. So let's use the material better. Tooling. So that's actually where our biggest expertise is, but, you know, I find that people usually care about, okay, how can I make better money with the lab? Like, that's really what the question is at the end of the day. And you know, Sierra is really an interesting company because we got our start because we wanted to address that exact simple concern. You know, back in 2008 when Sierra was founded and we partnered with Zahn, the status quo was bad in the tooling space. I mean, you had company or systems like the old lava form, the big giant industrial freezer looking machine. You know, you spend $250,000 on the machine, and then they were charging, you know, $50-$60 for a burr. Sierra really cut its teeth, no pun intended, on that system, because we came in with our aerospace technology. And yes, the tool costs more, but we 10, or in some cases 15x'd the yield of the tool. And so that has the effect of taking your cost per unit of production through the floor. I mean, we were going from like, you know, 50-60 cents in tooling per crown to like 7 cents. And that plus the partnership and marketing and support horsepower that Zahn has is the reason why we're the premier tooling supplier in the market now. So when you look at a tool, and obviously I'm biased, so I know that Sierra checks all these points, but hey, you know, there's other options. The biggest thing that you want to look at is, does the tool work with the machine and the CAM? It's got to be validated, and you have to question who did the validation, how did they do the validation. Just hearing the word validate is like whatever. You got to make sure that somebody actually tested it in real life and make sure that it works. Because there are nightmare stories that I can't, you know, really get into detail, but there have been tools that have gone out there that just didn't work from our competitors and caused a huge amount of issues. And then you want to look at, okay, is it quality? So if you get one tool for X price, is it going to be as good as the next tool and the next tool and the next tool and the 100th tool? Do you have consistency? Can you rely on it being repeatable? And then you got to look at the economics. You know, it's not just about what the tool costs up front. It's about your cost per unit. What does it cost you to make a crown with that tool? So I'm pretty confident that if you analyze those questions and think about it in detail, you fall on Sierra, because we're designed to hit those 3 points. No matter whose tool you're using, you need to be tracking what your usage is, because if you don't track what your usage is, you can't answer any of those questions on the prior slide. So how do you track units? Yellow pad. Just make hash marks. I put the tool in on this date, and I'm this, and this. Very, very simple. I mean, you can get fancy with Excel spreadsheets or whatever, but literally, a yellow pad or a sticky note on the side of the machine. Just at the end of the day, know how many units you did before the tool wore out, and then also be aware of the fact that tools wear in different rates depending on what tool they are. So for instance, this table here is it is a Roland with mill box single molar crown. So the 2 millimeter runs for 4 minutes, the 1 runs for 12, and the 0.6 runs for 2. So this is going to tell you you're going to replace that 1 millimeter a lot faster than the other ones. You want to know how to get into that scientifically? Reach out to me, and I'm happy to help. Okay. Oh, hey, I got a cool little icon in here. So if I'm going to leave 5 minutes for questions, I need to run through the last couple of these slides here. Little note on constant improvement. I like this this metaphor of 2 boats on the ocean, and if they have 0.2 of a degree of separation over time, those tiny little incremental changes add up to massive changes. Back to mindset. Another one on mindset. If you're unfamiliar with lean manufacturing, man, just Google it. Read the Wikipedia on it. Look at how Ford did it. Look at how Toyota did it. Look at how modern, other modern production industries do it. And there is a lot to learn from that and apply to the lab. If you don't measure it, you cannot improve it. I think that's a good theme on this this thing here. I like to measure things. If you don't know what you're getting out of a tool, you don't know if you can improve what you're getting out of the tool. Couple of details on that. Are you using the machine to its capacity? Do you like a machine running in 8 hours, how many units can it do? What percentage of that capacity are you using in your lab? Does it make sense to get another machine, or should you maybe focus on getting the one you have to work more efficiently? A lot of questions there. Track your off-machine reject rate. What I mean by that is how many units are you throwing in the trash because of chipping, surface, fit, things that happen maybe in the machining process that could be related to machine, calibration, cam, worn tool, many things. But if you're not tracking that, you can't troubleshoot it, and it's money going out the door. Examples of stuff that you'll reject a crown for. Okay. I'm going to run through the little pitch that we do on Sierra. These are the last couple of slides, and then I'll tie it up for questions. So again, we're the most validated tool out there. It's you can't argue with it. Everything we do is at an aerospace level, from our designs, our materials, our coatings. Everything is at the grade that like a company like Boeing or SpaceX would demand. And our offering is the most cost efficient from a per unit standpoint. And when we talk about validation, we mean it. We literally sit down and machine 100 or 200 or 1,000 crowns just to document the wear and know exactly what the tool does in that scenario. And so we can look at what the tool wear looks like. I'll point your attention to the edge of the tool. After 500 units, it starts to erode just a little bit. And then after 1,000 units, you have a little bit more erosion there. really the point of this one was, let's guarantee that we can do 1,000. But we have so many anecdotes of labs doing well over 1,000, close to 3,000. So it's all about the implementation and how you do it. I make this metaphor quite a bit, that tools are basically like tires on your car. If you go easy on them, you can get so many more miles on them than if you're doing burnouts in the parking lot. So with that, I think this is my second to last here. I hope that it's obvious that Sierra and Zahn together are really here to support the industry. We want to deliver real value that actually helps the lab. It's not just about selling a widget and walking away. And you know what? We're here to support it, start to finish. So I'll jump into the last slide, which if anybody watching this wants to reach out to Sierra to talk about maybe some process improvements or anything that may be indirectly related to tooling, we're always happy to chat about it. I kind of pride myself in thinking about the fact that Sierra is not just a tooling company. We're more of a solutions company that happens to make tooling. So I went over by 2 minutes, but I'll give it back to Fran and see if we have any questions, and we'll jump from there. So Fran.
Thanks, Greg. We did have one question, but I think you answered it, so maybe you want to reiterate a little.
Sure.
The question was, do you have an average number for units per tool?
Yeah. So it's really dependent on the machine itself and the material, because that varies. In fact, before we got this conversation started, we were talking about that. If you have a denser zirconia, it wears the tools faster. And if you're not updating your software and making sure your machine's upkept, you can also affect tool wear. But all that in, if you're machining a common zirconia, maybe like a Zerlux zirconia, and you're using our tool like in a roll-end with millbox, you can easily do 1,200 to 1,500 units with a tool set. And the way that usually breaks down is the 1 millimeter drops out around 1,200 units. The 2 millimeter will go closer to 2,000, and the 0.6 will likely end up around where that 2 millimeter is too, because it's kind of a smaller tool, has to work a little harder to do what it's doing. So if anybody has any specific questions, and we can talk about, like, all right, I need to know what machine, what material, what cam, I can give you a way better, more precise answer. But yeah, we advertise 1,000 units, but it's kind of a core principle that we want to under promise and over deliver. And really that's why we're built on that, and I probably need to get that word out a little more. But yeah, it's somewhat dependent on your setup, but we'll definitely hit the advertised rates.